Hello everyone, welcome or welcome back again to another video tutorial from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and of course in our previous upload we had looked at questions 1, 2 and 3 from the May-June 2023 past paper. So we're going to pick up from where we had left off in that video. Of course, if you did not get a chance to look at questions 1, 2 and 3, I will pin a link in the description of this video so you can go over there and check on that and then return to this one. All right, so we're gonna jump right into what we have to do for this particular video and get right into it. Of course, do not forget to hit the subscribe button below, turn on your post notification bell to be notified on a daily and weekly basis whenever it is that I post tutorial videos here for preparation for exams on a yearly basis. All right, so then let's jump right into it. Now we're looking at here is question 4 describes functions and relations, and here it is saying that consider the following functions. F of x equals 3 divided by x plus 2, and we have a g function that is 4x minus 3, and we also have an h function that is x squared plus 1. Now it says, for what value of x is the function f of x undefined? So now the key thing here is understanding what is meant by an undefined function. And so an undefined function is a function where the denominator of that function equates to 0. That is in fact then, we're looking at the f of x function then. So what we're looking at is taking, say here, x plus 2, and we're going to equate x plus 2 here to 0. And by solving this very simple linear equation, we end up that the value of x that will make this function undefined is that x is equal to negative 2. So what does this really mean? Well, when something is undefined in math, it means that, of course, the denominator is equal to 0, and you're going to get a math error if you try to divide by a 0. So if we were to take minus 2 here, just to prove that's 3 divided by, we say minus 2, that is x here, plus 2, you'll find that you end up with 3 divided by 0. And so, of course, when you try to divide something by 0, you're going to get a math error. And so the math error then proves that the function then is undefined. All right, so that's very simple, guys. An undefined function, you just simply take the denominator of the function and equate it to 0. All right, next one here, find the value of g of a quarter. So we're going to replace a quarter into the function that we see right here, that is 4x minus 5. So since we have then that g of x is equal to 4x minus 5, then we're looking at 4 multiplied by a quarter, and that's going to be subtracting 5. And so very easy then, 4 cancels 4, we end up with then say 1 take away 5, which easily works out here to be negative 4. All right, so g of a quarter equals negative 4. 1 mark, very simple. Moving right along, guys, h of negative 3 then implies that we're going to substitute negative 3 for x into the h function, and we have an h function that says x squared plus 1. So since h of x then is equal to x squared plus 1, we're going to look at h of, say here, minus 3. So that's going to be minus 3, and be sure to put it in a bracket, and that's plus 1. Bear in mind that if you do not put it in a bracket and you type it on your calculator, it's going to tell you negative 9. So you have to ensure that you square not just the 3, but you square also the negative sign as well. All right, so this easily then works out to be positive 9 plus 1, which therefore is equal to 10. For those of you who actually attempted this before and you actually got negative 8, then the reason for that obviously is simply because you squared the 3 and you didn't square the negative. All right, so you want to make certain of that, and just bear in mind that once you square a number, it's always going to be, say here, positive. Now we're looking at this very unusual one. It doesn't come up a lot, but it does come up occasionally. And this is f of 0. There's a couple of ways to do this. I'm going to show you both ways, in fact. All right, now the easiest way here is, in fact, let's just zoom up a little bit here for you. All right, so now what we're looking at here is f of 0. This means I'm going to take 0. Okay, I'm going to take the 0 and I'm going to put it into the f function here, and it's going to produce a result. All right, and that value that is produced by that function, I'm going to put it back into the f function again. Now, you're going to find occasionally in future past papers that you find here that sometimes it will be written as f squared x. So do look out for that one as well. Okay, so if you see that, it also means the same thing as fx or ff0. Okay, so you might see f squared, you might see f squared 0 instead. And so just in case you see that, that's what it means. So if we scroll back up here and we have a look at our f function, then that is 3 divided by x plus 2. So that's f of x equals 3 divided by x plus 2. We're going to take 0 and put it here. So f of 0 is then going to be equal to 3 divided by 0 plus 2. All right, and so when we work this out, we end up with 3 divided by 0 plus 2 is in fact 2. So this is our first substitution here, 3 over 2. We can therefore then find f of 3 over 2 because we're putting back the value that we just got back into the f function. So this then works out to be that this is 3 divided by 3 over 2 plus 2. We're then replacing the x here again with the new value that we just got. That's 3 over 2. Now, this requires us to do a little bit of working out at the bottom here. So we're then gonna go ahead and find the LCM of that fraction down at the bottom. So the LCM here is in fact 2, and so 2 divides into 2 goes 1 time. So we times the top by 1, and 1 goes into 2, 2 times the top by 2. So then we worked out this to be 3 times 1 is 3, and 2 times 1 is 2. So we end up with, say here, 5 over 2. That's the answer for what is at the bottom. So of course we're going to have to take the number at the top, the numerator, which is 3, and we're going to divide this then by, say here, 5 over 2. Easily then this becomes 3 multiplied by 2 over 5. And then our final result then is that it is 6 over 5. So therefore then f of 0 works out to be 6 over 5. All right, and that's what you call a composite function. Now alternatively then we can actually do it another way. We can therefore find the f of x function first. That's f. Okay, just a second here. So we can find the f of x function first. So we can therefore go ahead and find f of x first, and that is basically taking the f function and putting it back into itself. So we're going to substitute, say here, 3 over x plus 2 where the x is right here. And is this a harder way? Let me know in the comments, guys. So we're going to have 3 divided by 3 over x plus 2, and then of course we're going to plus 2 here. All right, now it looks a little bit challenging to me in my opinion, so I wouldn't want to recommend doing it this way, but therefore let's go ahead then and say here x plus 2 is our LCM. X plus 2 into x plus 2 cancels, well, it goes 1 time, so we times the top by 1, and 1 into x plus 2 is in fact, say here, x plus 2. Okay, so we put that in a bracket at the top. So 3 times 1 is in fact 3, and so therefore then we have 2 times x is in fact 2x, and 2 times 2 is in fact 4. So we then end up with what is at the bottom to be 3 plus 4 is in fact 7 plus 2x all over x plus 2. But of course, we know that that's just the result for what is at the bottom. Now we have to divide that then by, say here, 3 divided by, say here, 7 plus 2x over x plus 2. And of course, when we're dividing fractions, we're going to have 3 multiplied by x plus 2 all over 7 plus 2x. All right, this is a much challenging way to do it, but it's an option, so we must consider it. And so therefore then we end up now with 3 times x, that's 3x, and 3 times 2, that's 6. And that's going to be all over 7 plus 2x. Now all we have to do then is just substitute 0 into this function. So that's going to be 3 times 0 plus 6. And that's going to be all over 7 plus 2 times 0. And finally then, 3 times 0 is 0 plus 6. And that is equal to 6 all over 2 times 0 is 0. 0 plus 7 is 7. So we end up back with the similar result here. I think I may have made an error somewhere. Not 100% sure, but we're getting 6 over 5 up here, and we're getting 6 over 7 here. So I need to verify on that answer. Just a second, guys. Alright, so I think that I made an error right here, guys. And so that's why it's always very important to check over your work. Here, I actually said 2 into 2 goes 1 times, and I actually said 1 into 2, I wrote times 1 here. I actually should have written times 2 here. So that was the mistake here. So let's just adjust that then. That's going to be, say here, times 2. And then, of course, 2 times 2 is in fact going to be, say here, 4. And so 3 plus 4 works out to be here, say, 7. And then of course we're going to transpose, going to bring that 7 down here. So we have 3 divided by 7 over 2, which therefore then becomes 3 multiplied by 2 over 7, which therefore then works out to be 6 over 7. So both our methods work. Again, it really boils down to you having the knowledge to work it that way. Do I recommend you doing it this way? Your algebra skills must be up to par. So it's far more beneficial and easier if you do it. Just plug the number into the function. Alright, so always here we just learned something from this. Always when we do a question, guys, let us try to do the question and ensure that we check our work solutions. Because if you move too fast or too slow, then you might make that odd error that might throw you off. Alright, so that's it. Let's continue then on to the next question. Now our task here is to write an expression in its simplest form for GHX. So GHX then implies that we're going to plug, say here, the H function into the G function. So the H function becomes our substituted expression. So therefore then we're going to end up then with G of whatever H of X is. And I believe H of X was X squared plus 1. Let us just quickly confirm that then, that H of X is in fact X squared plus 1. So we're going to plug that right into the G function. Now we know that the G function here is 4x minus 5. So we know then that G of X is in fact 4x minus 5. So that's going to be 4 open bracket x squared plus 1, and of course we're going to subtract 5. So 4 times x squared is 4x squared. 4 times 1 is in fact 4 and minus 5. So simply 4x minus 1. That is our simplified expression. All right, and they say write it in its simplest form. Well, the simplest form of this, well, this in fact turns out to be a difference of two squares, because the 4 here works out to be 2 squared, and the x is already squared, and the 1 can be squared. 1 squared is 1. So this then brings us to the simplest form, would have been open 2 brackets. That's going to be 2x in one and 2x in the other, plus in one bracket, minus in the other bracket. 1 is here and 1 is there. So they wanted the answer to be in its simplest form, which is in fact a difference of 2 squares, which is this answer here. All right, nice question there by Csec. Really enjoy that question. Now we're going to be looking at G inverse minus 2. And so in our previous video, we had looked at an example of how to find the inverse. Now I do not have a tutorial video on inverse functions, but here are the steps. Now we have that we must make y the subject of the function. So we're going to replace g of x with y. So that's y going to be equal to 4x minus 5. So we let y equal to the g function. We're going to interchange x with y. So that's going to be 4y minus 5. Then we're going to isolate y. So then we're going to have, say here, x, subtract 5. I'm going to add 5 to both sides, or just transpose negative 5. I'm going to get x plus 5 equals 4y. And so I'm going to split the product of 4y. So I'm going to end up with x plus 5 all divided by 4 is therefore then equal to 4y divided by 4. Cancel. So therefore y is equal to x plus 5 all divided by 4. Now the moment that y is isolated, then therefore g inverse x equals then to x plus 5 over 4. But they had asked us for g inverse negative 2. So we're going to substitute negative 2 in here. So that's g inverse negative 2. That's going to be equal to negative 2 plus 5 over 4. And then that works out to be 3 over 4. Really, really nice question then. All right. So that wraps up that part of functions for you guys there. All right, ensure that you hit the like button if you are getting some clarity. Leave your thoughts and comments down below. Let's move on then to the next question, question 5. Now we're looking here at statistics, and each of 75 girls recorded the name of their favorite sport. The number of girls who chose track and cricket are shown in the bar chart below. So here we have swimming, we don't know what that is as yet, tennis, empty, track. You can see that this scale here is going up by a 1 to 2 scale, so it's 1 centimeter to represent 2, so that's 2, 4, 6, 8, 10, 12. So we know right away that this bar here, track, is in fact on 12. All right, and then of course we look here that this bar is in between 16 and 18, so this is definitely going to be 17. So here we know for certain that this is 18 here, and this bar is right in between. That's going to be, say here, 17. All right, so that's just an assessment. Football, we don't know what that is. Let us just continue. It says here, how many more girls chose cricket than track? How many more girls chose cricket than track? Now we know based on our assessment that the number of girls that chose cricket was in fact 17, and we know that the amount of girls that chose track was 12. So 17 take away 12, 5 more girls chose cricket than track as your favorite sport. Very simple then. Moving on, 11 girls recorded tennis as their favorite sport. For the remaining girls, the number who chose swimming compared to the number who chose football was in the ratio 2 to 3. Use this information to complete the bar chart above. All right, this is very interesting. Very interesting question here by Csec. So now we know for certain that we're getting some additional information here. It says 11 girls recorded tennis as their favorite sport. So let's just complete our bar chart here. All right, so 11 here. So 11 is going to be, this is going to be 8, this is 9, this is 10, pardon me. In between here and here is it going to be 11. So we're going to bring the bar up from here, all the way up in between here and here. Let's just draw that a bit straighter. Okay, right in between here and here. Come across like that. Come across down like that. That's going to be tennis. Let's just shade that amount right there. Now, we know from the beginning of the question that 75 girls was recorded, 75 girls recorded the name of their favorite sport. So already we know that this is 11. And we also know that this is, say here, 12. And we also know that this here is 17. So I can do a little bit of calculation here. I can therefore then go ahead and let's just zoom up here. Let's do the calculation over this side. We know that 11 plus 12 plus 17, let's just add that together. So 11 plus 12, that is definitely 33. That's, pardon me, that's 23. 23 plus 10, that's 33. 33 plus 7, that is 40. So we know information about 40 of the girls. Now, since there were 75 girls in the whole entire survey, we know that 35 girls then was left that didn't really specifically state what their favorite sport was. But we do know, according to this information, that swimming compared to those who chose football was in the ratio 2 to 3. So swimming to football. So okay, so let's just write a ratio here. Swimming to football. And the ratio is 2 to 3. So we know right away that the TP, that is the total proportion, that's going to be equal to 5. So right away I know that since there are 35 girls in total that is left over, those 35 girls would have selected swimming and football respectively. So right away I know that the 35 girls divided by the total proportion will give me what is the value of one girl. What sport did one girl choose? So 5 into 35 goes 7. That means 7 girls chose, 7 girls represents one proportion. So we know for certain that since swimming is 2, we know that that is 2 times 7, and that's equal to 14. And of course we know here that 3 times 7, and that is 21. So we know that 21 girls chose football and 14 girls chose swimming. So let's go on our graph then and put our 14 and our 21 for swimming. So 14 for swimming. So we're going to have here, this is 12, this is 14 right here. So we're going to come up here, come across like this, come here. That is swimming, that's 14. We're going to shade it then. And then for football, it's 21. So that's all the way up here. Okay, so that's going to be 21. So that's 20. This is 22. That's in between here. That's 21. We're going to come all the way down here. And all the way down here. And we're going to shade our bar chart. Alright? Really, really nice. So it's very interesting by Csec here that merged a little bit of ratio with statistics, and we did not, in this particular year, we did not get our traditional statistics question, which is cumulative frequency. So it was a very refreshing question, and this is really, really nice considering that most students would have been preparing for the cumulative frequency. So if you were a student in that particular year that did this exam, then that is the solution to that question then. All right, now next part says here that we should determine the modal sport. Obviously the mode is the frequency that occurs the most. So which sport here had the most which sport was chosen the most by the girls? Well, we already established that football is in fact 21. So the mobile sport then obviously is going to be, say here, football. All right, let's look at then part D of the statistics question then. One of the girls is selected at random. What is the probability that she chose neither track nor cricket as her favorite sport? So neither track nor cricket. Let's first look at the probability formula. We know that probability is equal to the number of favorable outcomes divided by the number of possible outcomes. So therefore, the number of favorable outcomes divided by the number of possible, we're looking at finding the favorable amount, and you're looking at what's the probability that she chose neither track nor football. So neither track nor football. What's the probability that she chose neither? Okay, what's the probability? So we need to find out how many students chose track and cricket together. Okay, so track and cricket. Track and cricket we said was 12 and 17 respectively, which worked out there to be 29. Okay, so we know right away that track and cricket was 29. So track plus cricket equals 12 plus 17, which is equal to 29. So therefore then neither would have obviously been 75 girls minus the 29 that chose track and cricket. And then therefore that works out to be, say here, let's see, that's 30, that's 45, that's 46. So that means 46 persons chose other sport. 29 chose track and cricket. The question asks what's the probability that she chose neither. So what's the probability that they chose? In other words, what's the probability that they chose the other three sports? That would be 46 then divided by 75. So it's the number of favorable, which is neither track nor cricket, and the possible is 75. So if we hop onto our calculator here, then you'll find here that 46 divided by 75 gives us a probability of 0.613, or so 0.61, or you can say 61.3%. Okay, so there's a 61% chance that she chose neither track or cricket. All right, beautiful, nice question then. Now let's move on to part E. The information on the favorite sport 75 girls is to be shown on a pie chart. Calculate the sector angle for football. Now, to calculate the angle on a pie chart, we know that it's going to be the number of, in this case here, it's the number of girls that chose that particular sport. So in this particular case, it's going to be the number of girls divided by the total girls, and of course, because we're looking for the angle on a circle, a pie chart, we're going to times that by 360 degrees. So since we can go back, then we can double check that football was in fact 21. Okay, so let's just scroll back here. That's 21, and we're going to divide that then by 75 girls, and we're going to times that then by 360. If you wanted the percentage, then we times it by 100, but we wanted the sector angle, so that's 21 divided by 75, and we're going to times that then by 360 degrees. So it works so that it's approximately equal to 101 degree. Well, it's in fact 100.8, so rounding off, that's about 101 degree. That is the sector angle for football. All right, so hopefully you guys got a hang of that. Then we've just completed question 4 and 5. Let's just wrap up then, say here question 6, and possibly here say question 7. All right, now in this question, take pi equals 22/7 and the volume V of a cone with a radius R and height H, as V is equal to 1/3 pi r squared H. You guys have gotten a clue. So they've given you the formula of the volume for a cone. All right, now in the diagram below shows the sector OMRN, which you can clearly see here, guys, OMRN, and of a circle with center O. Radius is 12, which you can clearly see here, and the sector angle is 168 degrees, which is right here, which also forms using a thin sheet of, which was formed using a thin sheet of metal. Calculate the perimeter of the sector above made from the thin sheet of metal. So we all know that perimeter means distance around. So it's going to be this distance here plus this distance here plus all of this curved distance around here. All right, now we know that since O is the center of the circle and ON is 12, then OM also is 12, because radii of the same circle are equal. So this is 12. So we now need to go in search of finding this curved section here. Now if you scroll, because sometimes when I do scroll here, it sometimes makes the page disappears, but if you go at the top of your booklet, just skip the front of your question booklet on your Csec past paper, you will go at the front and you see a formula that states that it's the length of an arc. Okay, length of an arc. So we can go back then and check on that the length of an arc, or they say arc length, it's a length of arc is in fact theta divided by 360 multiplied by 2 pi r. Okay, so the sector angle here is 168 degrees, and that would be divided by 360. Then we're going to multiply that by 2, and they did instruct us specifically to use pi as 22/7. And the radius here we have already established is in fact 12. All right, so that's 2 multiplied by 22/7 times 12. Now there's a couple of cancellations that we can do, but it's going to be more or less the same if we use our calculator. So we're going to go ahead and say 168 divided by 360. Let's write that down. That's going to be 0.466 recurring. So that's 0.466. And we're going to multiply that by 44. Then we're going to multiply that by 12. The 44 is because of the 2 times 22 times 12, and we're going to divide everything here then by, say here, 7. Okay, because we have already cancelled the 168 and the 360. All right, so then we're going to go ahead and 0.466 multiplied by 44 multiplied by 12, and then we're going to divide that answer then by 7. So we get a arc length here that is approximately equal to 35 point, say here, 15. Okay, centimeter. Let's double check if it's this unit. Centimeter. That is correct. So that's the arc length. So therefore the total perimeter then of this particular display here is total perimeter is equal then to 12 times 2, or 12 plus 12, and we're gonna plus then, say here, 35.15. okay, 35.15. so therefore then 35.15 plus 12 plus 12, or 12 times 2, then we worked out that the total perimeter around this shape here is in fact 59.15 centimeter. All right, and that again was a really nice question here by Csec. Definitely nice question then, and it was worth it. 3 marks for this much calculation. It was worth it. Let's move on then to part B here. A cone is made from the sector that in A by joining OM to ON as shown in the diagram below. All right, no problem. So basically then this particular shape was joined on together. So we joined OM here, that is OM here, we joined this line to this line, and it created the shape that we're looking at the bottom. All right, so if you guys know anything about net shapes, then you'll know that that particular shape there is in fact the exact shape for a cone when it's opened up. Now this is the cone that we're looking at. Then it says we should calculate the radius of the cone, so we need to calculate the radius here of the cone. All right, now we need to connect somehow this diagram up here with, say here, the diagram down here. All right, so basically then when we look here back at this diagram, right, this curve section that we just calculated here, once you join MO to ON, basically that becomes one side, and so it becomes the slanted side to which we're looking at here. So MO here, and of course here you can see that N is also that same position because they are one line. And so basically then this curved section here, this curved section around here is basically going to be the circumference of the base. So that curved section here is going to be all the way around here. All right, that's the imagination part of it. So then in order for us to find the, say here, radius, we're going to have to use the circumference formula because we don't know anything about the area of the circle. But what we do know is that the distance around this section here we had calculated just moments ago to be 35.15. So right there and then, now we know for certain that since circumference then is equal to 2 pi r, then since the circumference is going to be 35.15, that's going to be equal then to 2 times 22 over 7 times, of course, the radius which you're looking for, which is r. Okay, so therefore then this becomes then 35.15, and that's going to be equal to 44 over 7 multiplied by r. So if we're going to isolate r, we can therefore then divide both sides by 44 over 7. So that's 35.15 divided by, say here, 44 over 7, and that's going to be equal to, say here, r. All right, and so of course 35.15 multiplied by 7 over 44. Okay, that's what happens when we're dividing a fraction. So let's go it. 35.15, we're going to multiply that then by 7, and then we're going to divide that by 44. So the radius then works out to be 5.59, which approximately works out here to be equal to 5.6 centimeter. Okay, so the radius here is in fact 5.6 centimeter. All right, now the height of the cone then. Now since we know a couple of information here that the radius is, say here, 5.6, and we already established that MO is in fact 12 centimeter, we can therefore use the Pythagoras theorem then to find the height here, because you can see that it creates a right angled triangle. So this is a nice mixture question by Csec, merging measurement with trigonometry. Okay, so therefore then we know that because we're dealing with a right angled triangle then, and we're looking for this side then, say here, and this side is already 12, and this we just calculated to be 5.6, then we know that the Pythagoras theorem is going to be applied here. All right, And so therefore let's go ahead and do that. So now what we're looking at then is c squared is equal to, say here, a squared plus b squared. Okay, and so c is going to be the hypotenuse, which in this case is 12 squared. And so of course a squared is going to be 5.6 squared, and then that's going to be of course the unknown side here, which is the height squared. Okay, so 12 squared is 144, and that's equal to 5.6 squared. That's going to be equal to 31.36, and that's plus h squared. Okay, so subtracting 31.36 from both sides, that's 144 minus 31.36, and that's going to be equal to 112. So let's just write that down. 144 minus 31.36, and that's equal to h squared. Okay, so therefore then subtract 144 minus 31.36, that's 112.64, 112.64, and that's equal to h squared. So therefore then easily then h then is equal to the square root of 112.64. Okay, so that's the square root of 112.64. that works out to be 10.6, approximately equal to 10.6. all right, and that is the length, that is the height here that we have, 10.6. all right, so nice application question here, which means that students, if you are in fact unable to find the radius here, then it almost therefore means that you cannot go any further, because that 5.6 then was what aided us in finding the solution to part B here. all right, nicely done. So that was a nice question yet again by CXC. Really enjoyed that one. Let's then look at, say here, calculate the capacity of the cone in meters. The capacity meaning the volume of the cone. So volume is equal to, and it so happens that they were very kind enough to provide us with the volume formula right here, that is 1/3 pi r squared h. So that's 1/3 pi r squared h. So 1/3 pi r squared h. So the volume then is equal to 1/3 multiplied by 22/7 multiplied by 5.6 squared, and of course multiplied by, say here, 10.6. all right, you can see that the two answers that we just got is exactly what is needed to solve this final question here. all right, now that's going to be then volume is equal to, let's go ahead and square the 5.6. We had done that when we were doing Pythagoras theorem, which is 31.36. so that's going to be, say here, 1/3 multiplied by 22/7 multiplied by 31.36 multiplied by 10.6. okay, and we can just go on our calculators then and punch everything in. So that's 1 multiplied by 22 multiplied by 31.36 multiplied by 10.6, and that's equal to, at the top, volume therefore is equal to 7,313.15, all divided by 3 times 7 is in fact 21. So we're going to divide this by 21, so that's 7,313.15 divided by 21. So the volume of this cone then works out to be 348.25 cubic centimeters, and that's approximately equal to 348.25 cubic centimeters. all right, really nice then. all right, so that brings us to the end of question 6. That's going to bring us then to question 7. So we're going to be finishing up in part 3 here, question 7, question 8, 9 and 10. Of course, these particular past paper questions, I want to keep you guys very focused for a short period of time, so that's why I'm doing the questions in parts. All right, so I'm going to see you in question 7, 8, 9 and 10 in our next upload. So until then, take care. Please like, share and subscribe, and leave your comments, thoughts and opinions down below. Until then, take care. Bye bye.